Hello and welcome to Malfind Labs channel. I am Laskew and today I will show you how to set up your very own malware lab in Hyper-V on Windows. Until recently I was using VirtualBox as my hypervisor, but since I had to migrate my environment to the new workstation, I decided to take this opportunity to set up this new lab on Hyper-V and to record it so you can follow me step by step in configuring analysis environment. This is a simple lab using only 2 virtual machines, but for me personally, it is more than enough to analyze 95% of malware cases I had so far. If you're interested, please stay with me and I hope you will enjoy this video. So in order to create your own virtual environment for analyzing malware, you will need 2 virtual machines, and the first virtual machine will be the Windows virtual machine, and this is our main machine where we will execute and analyze malware. So it will be the one that will get all the fancy stuff for analyzing malware, and we'll execute our samples there, and it should be isolated. And the second one is the man in the middle proxy machine. So in my case it's an Ubuntu 20 machine, and it will serve as a proxy for entire traffic from this first machine. So this machine won't be directly connected to the internet, it will go through this machine, so we can analyze and decrypt even the traffic generated by malware. So in order to install these 2 machines, you need obviously 2 images, one Windows image and one Ubuntu image. You may choose some images that are pre-prepared in Hyper-V environment. So for Windows, you can use Windows 10 Dev environment from Microsoft, and it's completely free. The only downside is it's 90 days evaluation, so after 90 days you will have to reinstall it. Or you might choose, as I did, to use your own image of Windows 10. You can download ISO directly from Microsoft site, but you will of course need a license to enable it. And for Ubuntu, you can actually choose the one from Hyper-V. It's theoretically a little bit better optimized to run with Hyper-V, although my first impression is that this Ubuntu machine is quite slow in Hyper-V. I don't know why. I used in the past Debian for the same purpose in my VirtualBox environment, and it was much faster. But this is not really needed to be really fast, because we won't be doing that much on this machine. It will only serve as our traffic interceptor. So you can install Ubuntu from here. And I already have these 2 machines installed, but the installation is pretty straightforward. If you want to create a machine from Microsoft image, you just click a create virtual machine here, and it will download the image. I will cancel it because we already have it here, and then it will let you choose basic settings for this machine, like amount of memory, number of processors. Actually should increase that, probably I was testing something. Yeah, so I advise to give at least 4 gigs or 8 gigs memory on. You can choose to enable dynamic memory, so Hyper-V will choose how much memory does machine need. Installation is pretty straightforward, like I said, and I already have this installed. And then I will show you how to configure them and how to install everything on these machines. So let's first configure and install software on our Windows virtual machine. I have it already launched here, and like I said, it's quite a clean installation. I only installed some Office applications, and in order to install all the tools we need on it, we'll use the project that is called FlareVM. and it's available on the FireEye GitHub, and if you want you can read here a little bit more about it. It's basically a PowerShell script that will turn your Windows 10 installation into very powerful malware analysis virtual machine. We will install it. I already downloaded it here and unpack it. Let's just run it. I think you need to run it from the admin console. Yeah, and I want to run this script. And now it will install. It will take some time, so I will fast forward this part. So after the entire installation process is complete, this will take quite some time, so just be patient. This is how your VM will look like. So the most obvious change is your background, but you have a Flare directory on your desktop that will contain most of the tools included on the machine, and there's, like I said, a lot of them. There are some Android tools, there are debuggers like Oli, X32, SCD, etc. The compilers, these assemblers, all the important ones, though of course it's only IDA free. If you have IDA license you need to install the IDA Pro yourself. You have some .NET tools, some forensics tools, some other tools to analyze Office documents like Oli toolset, and a lot of utility applications, etc. There's so much of them. I won't go through each one of them to tell you what it's doing because it would just take a long time. You can read about these tools online, or many of them I will be using in future videos when analyzing malware, so you will learn how to use them by watching my videos. So after the installation we need to somehow connect the machine to the internet. So right now it's connected directly to the internet, and this is not the best way to do it because we want our machine to be isolated, but we also want to be able to analyze the traffic from this machine to the internet. So what we're gonna do is we're going to set up another virtual machine that will serve as a proxy, and to do that we first need to define some virtual switches in the Hyper-V environment, and I already defined two of them. So you basically need one external and one private virtual switch. So I called my private virtual switch malfind, and the external switch is just external switch, and it's connected to my Ethernet card. So after we have these switches, we'll focus our efforts on configuring the second machine, and after that I will show you how to use these switches to connect them together and to make them work together as a proxy. So on our fresh installation of Ubuntu we need to configure two network interfaces. So you want to add the one network adapter, I already have it added here. So we have two network adapters. One is connected to the external switch that we just created, and the second one is connected to the private switch that's called Malfind. And we use these two network adapters to use this machine as a proxy. And for that, we need to install some software. And first thing we will install is the SSH server. We use that to connect to this machine and to transfer files to our Windows machine. I will show you how later. So let's just install. The Open SSH server. Okay, the next thing we will install is Inetsim. So this is a tool to simulate network environments. I will show you how it works. We also want to set up one folder, let's call it share, that will allow us to share the files with our analysis machine. So in order to transfer files to and from the Windows machine, we will send the files to our Ubuntu machine, and then we'll put them in this shared folder, and this shared folder will be visible from Windows machine. So basically the goal here is to have this Windows machine as much as isolated as possible, so we don't want it to have direct access to our underlying host. So we won't share this directly to our underlying Windows machine. We will share files to our Ubuntu machine. That reduces the probability of infection and of escaping the virtualization. And even if we get infected, it will be our Ubuntu machine that will get infected, but it's highly unlikely that any Windows software will infect Linux software. It can happen, but it rarely happens, and this will just basically make our environment much more secure than if we shared it directly to our underlying host. And to do that, let's enable local network share, and for this we need to install SMB. So let's do it fast, and there's a problem. Okay, so apparently installing Samba from the terminal is a better option. This way it works. Anyway, we need to share this folder. We'll make it fully accessible, so we can actually share the files from and outside of the Windows machine. So the last thing we're going to install is Burp Suite tool. In order to do that, we need to go to their site. The community version will be enough, more than enough for our purposes. We only need it to serve as a proxy. We won't be doing any network scans with it or anything. So let's download the latest version for Linux 64 bits. So this download took much longer than I expected it to be. Seems to be some issue on Burp servers, because my network connection is still okay, but never mind. Since we already downloaded it, let's install it. So after installing our tools, let's configure them. So we start with configuring Inetsim, and to do that, let's copy its config to our home directory. After we do that, we can edit it. And there's a few things we need to change. So here are listed all the services that it will start. It's okay, we mostly care about HTTP and HTTPS. But what we need to change here is service bind address, because we want it to bind to not only local host, but all of the interfaces actually. Next thing we need to change is DNS default IP. So every time there will be DNS request to our fake DNS that will be run by Inetsim on port 53, it will return the value 10008, which is our internal interface. So this will assure that all the traffic will be directed via this machine. And next thing to change is the bind port for HTTP. So we change it to 8080. So the way it works is our Burp suite that we will configure in a second will listen on the port 80 and 443 for HTTPS traffic, and it will intercept this traffic, display this traffic to us. We can even modify this traffic if we want. Then it will forward it to the Inetsim that will simulate our network. So we need to change HTTP and HTTPS bind port. So they won't collide with our Burp suite. So let's save it. Let's go to our Burp tool. And now we need to configure our Burp suite. So in order to do that, let's just start it. Let's turn off the interception. And we remove the default interface, default listener, and we'll add two of our own listeners. So the first listener will be bind to port 80 on all interfaces, and it will redirect everything to our running Inetsim on port 8080. And we just check the support invisible proxying as well. So this is the first listener, and the second one will be for encrypted HTTPS traffic on port 443. And we redirect to 8443, that will be the simulated environment from Inetsim. And I just forgot to check that it should run on all interfaces. And once we have it, we can save it for future use. I like to call it simply fakenet.json. And normally should be enough, but there's one last thing to do. So I actually ran Debian before, and that kind of configuration I just showed you was enough to run the simulated environment. For Ubuntu, there's one more problem I run into. So it has this specific network manager that does this strange thing with the internal resolver, and that means that our resolve.conf file, you need to put these two name servers in your resolve.conf. It will normally have something like name server 127 .0.0.53, and this is some kind of strange things that Ubuntu is doing to run its internal network resolver inside the and it will just basically change your configuration file every time, and you will run every time you bring up some interface, and you will run into problem with DNS resolution. So in order to do that, just do this, change this. But if you only do this every time you bring up the interface, it will be automatically replaced with the old config file. So the next thing you need to do is in the etc network manager conf, you just add this line DNS equals none, and when you do this, this will disable this functionality of the local resolver, and it won't overwrite your resolve.conf file, and this way we can run our own resolver, and we shouldn't run into any issues anymore. So let's test it, because we want to run it in the isolated environment. I will turn off our external connection, which is ATH0, because we won't need it, and it can cause some problem with internal routing if I leave it enabled. And just run our Inetsim with our just created config. And our Burp with these two listeners that is already running. Last thing we need to do on our Windows machine is to change the network adapter to internal traffic to our private switch, and then change adapter options, set a correct IPs here. So we set it as 10.0.0.2 with subnet mask of 255.255.255 with default gateway of our Ubuntu machine and the DNS server of Ubuntu machine as well. And if you connect anywhere, let's just connect to http google.com, and you can see this beautiful Inetsim HTTP server fake mode default page. We can of course customize it in our Inetsim environment. For now we're running the default stuff, and here in our Burp you can see the intercepted traffic, and anything that will go from this machine to the internet will go to our simulator environment instead and will be intercepted by Burp. So even some internal traffic like the connection test and everything, and of course all the malware traffic as well. So that's great. One thing that's still problematic is doing HTTPS connection. So if we go to https google.com, this will be this strange thing. It's basically the connection is not secure, the certificate is not valid because it's issued by PortSwigger. But in order to make it better, because not every malware will connect if the connection is not secure, let's go back to our Burp suite, and there's something like import export CA certificate, and we can export it in the DAR format and export it as burp.dar, save it, and it was exported successfully. We can go to our home folder and put it in the share folder, and because we already shared our share folder as a SMB share, we can connect to it actually from our Windows machine and just simply copy, we can connect to it from our Windows machine and simply install it on our Windows machine. And we want to install it for the entire machine and place it in the Trusted Root Certification Authority store. And once it's imported, we just restart our browser. We can even put like random address, it doesn't matter. But if we want to go to Google, you can see that HTTPS is now considered secure, so there's no warning about the traffic being insecure. So this is our simulated environment. What if we actually want to send the traffic to the real network, real internet, but we still want to intercept it with our Burp proxy and possibly modify it or just read it? Then we can do this. We will need a new configuration for our Burp and a new configuration for our Inetsim. So in order to do this, let's copy our Inetsim config as inetsim dnsonly.conf and edit it. We need to remove all the services because they won't be needed anymore. So I will just remove them. And we still want to bind to address 000, that's okay. And we still want to send 10.0.0.0.1 as a default IP. So what we're doing now, let's save it. What we're doing now is just basically using Inetsim as a DNS resolver. So we want it to send all the HTTP and HTTPS traffic to the Burp proxy first, and then Burp proxy will reroute it directly to the internet this time. So for this we need to re-enable our external connection, so we even able to connect to the internet. And then we need to run our Burp proxy. Let's already run our DNS resolver, so now we want to run it with our second config. And now it will run only the DNS service. And we also need to run our Burp, of course. Create a new configuration this time. And the configuration is actually really similar. So we remove our default listener and we again add two listeners. This time we also bind them to port 80, only on this specific interface. And we redirect them this time to also to the same port, but we'll make it might seem quite strange why redirect from port 80 to port 80, but here we will make a use of the internal routing of Linux. So it will basically reroute it to the default gateway, and the default gateway will be our external IP. So we just make use of the internal routing for this. And we do the same for traffic, for HTTPS traffic. And it seems to be already working. So let's go to google.com. And now we're running in the internet. As you can see, everything is running smoothly. So now we have this configuration, we can save it and save it as a realnet.conf. And what if we need to go back to the simulated mode again? We don't need to change anything on our Windows machine, and that's the beauty of this solution that I like. We turn off HEH0, which is our external connection. We close our Burp suite. We stop our Inet environment. We run it again with the fully automated, fully simulated environment config. It will launch all the services. We run our Burp again. We have already our FakeNet profile saved here. The only thing we need is to turn off the interception because it's not saved with the profile, and as you can see, it's already serving even to the background traffic, it's serving the simulated traffic. So if we just refresh it, now we're back into the simulated mode. So that's the beauty of this solution that I like. It's just take us a few clicks to switch between redirecting traffic to the internet and to the simulated environment, and we can see everything in our man-in-the-middle proxy. So last thing I want to show you is if you ever want to install something new on your Windows machine, and for downloading bigger files you don't really want to use this man-in-the-middle proxy connection because it's a really nice solution, but it will have some performance issues when downloading bigger files, obviously, because everything is going through Burp proxy. And for this, I have a simple script here. It will switch your interface from directly connected to the internet from DHCP mode to the one that is right now set. So right now we are on the 10.0.0.2 IP. And if you want to switch to the internet directly connected and don't go through our man-in-the-middle proxy, we just make it just 2 steps. So we switch our virtual switch to external, and then simply run this script. Only you need to do the shortcut on the desktop or wherever you want, like this. So you can actually enable it to run as admin, because it needs to be run as admin. So that way you can just basically double click on it. And now we should be switched to the internet. It's not recommended if you're running any malware on it, but if you want to install something and you are on the clean checkpoint, on the clean snapshot, then you can do this. If you want to switch back, just switch to the internal network again and click our script again, and boom, now we're in the simulated environment running via man-in-the-middle proxy again. So how we actually transfer malware into this machine, because this machine is right now quite isolated. So there are multiple ways, but the way I like is this one. So we already set up this share from our Ubuntu machine into this machine. You can even disable this sharing when running malware if you're really scared that malware somehow will escape your host via this share. So if running malware, you can disable it, but to copy malware into this machine, if you have it enabled, you just use WinSCP to connect to your Ubuntu host. Okay, now we can copy basically anything we want. Don't have any malware samples right now here. but let's copy our Office installer from download folder. And now we have it directly on our malware machine, malware analysis machine. If you want to analyze it, just copy it to the desktop, as that's the purpose of this machine, to have harmful files on it. As I said, if you're paranoid about the malware you analyzing, and you should be, then you just switch off the sharing. And now you're ready to go. This is completely isolated now, and you can analyze your malware. And that's it. Your environment is ready to go, and you can go on analyze stuff. I really hope you liked this video and have learned something while watching it. I have linked some useful additional materials in video description, so please check this out. If you have any questions or feedback, please drop the comment below. And of course I will appreciate like and subscribe if you enjoyed the content. Cheers, and until next time.